Now we start with another type of question based on the fundamental theorem of arithmetic. The question in this type of question the value will change. It can be written like this. It can be framed like this. Show 12 raised to the power of n, or 6 raised to the power n, or 4 raised to the power n cannot end with 0 where n is a natural number. What does it means? Say the number of the type 12 raised to the power 200, say, or 4 raised to the power of 16, or 6 raised to the power of 5. To whatever power you raise these numbers, they are never going to end with 0, and with certainty we cannot say, and we cannot even solve each and every part. That is why we are going to make use of fundamental theorem of arithmetic. The question answer can be divided into two subparts. First part, let us see the numbers which end with 0 are basically of the type, say, 10, 20, so on. So when we find out the prime factors of 10, you will have 2 into 5. The only prime occurring are 2 into 5. That means, or when we find out the prime factors of, say, 20, so this will be 2 into 2 into 5. So the essential primes occurring which makes any number ending with 0 are 2 and 5 both. So 2 and 5 both should come in any number which is ending with 0, or it can be some their higher powers of 2 or higher powers of 5, but both should be available in any number which end with 0. So this is one fact you keep in mind. Now we go with the second fact. Let us do the prime factorization of 12. So prime factorization of 12, the first prime 2, then the next prime is 2, and the next prime is 3. 4 3s are 12. So the only primes occurring here are 2 and 3. 2 की power 2 into 3, or 6 to the power 6. Only primes occurring are 2 into 3. Or if we take the number 4, the only primes occurring are 2 and 2 only. What happens when we raise them certain higher power? So the prime factors will remain same, and the prime factors will occur in that order. If it is 6 raised to the power n, so the only primes occurring will remain 2 and 3 only. Same goes with the number 4 raised to the power n. The only primes occurring will be 2 and 2 raised to certain power. So we conclude. So we find that the required primes to make these numbers end with 0, make these numbers to end with 0, that is 2 as well as 5. 2 as well as 5, that is 2 and 5 both should be available, are missing here. Hence these numbers cannot end with 0. Okay.